This is Gas Laws Lecture number 6, STP. STP stands for Standard Temperature and Pressure. The standard temperature and pressure is a reference point that we use for tabulating data. We could pick any temperature and pressure combination, but an easy one that was chosen many, many years ago is 0 degrees Celsius and 1 atmosphere. We definitely need to know that. So 0 degrees Celsius and 1 atmosphere. Now we know 0 degrees Celsius is going to be 273.15 Kelvin. So this is 273.15 Kelvin and 1 atmosphere. And it's defined to be exactly 1 atmosphere, so the 1 atmosphere doesn't influence our significant figures. What we want to do is derive the volume of 1 mole of a gas at STP. That is a reference point that we use quite a bit in chemistry and physics. So if we go to PV equals nRT, and we said, okay, we want to find the volume of 1 mole of a gas at STP. STP gives us these two variables. Then we can solve for that. We'll say, okay, the number of moles is 1, exactly 1, and the pressure there, 1 atmosphere, exactly 1 atmosphere. So we're not going to have a limit on significant figures there. The temperature is 273.15, 0 degrees Celsius. And then the volume is going to be our unknown. We'll plug that in. We'll say, okay, 1 atmosphere times the volume equals 1 mole times R, 0.08206 liter atmospheres per mole Kelvin. And remember, with any PV equals nRT calculation, if this is the R value we're using, then we must use these units. Temperature is going to be 273.15 K. Obviously, we're going to divide both sides by 1. And so if I multiply 0.08206 by 273.15, I'll get a volume equal to 22.41 liters. We call this the molar volume. The volume of 1 mole of any gas, it does not matter. The gas could be nitrogen, it could be helium, it could be argon, it could be oxygen, is 22.41 liters. This is 22.41 liters. So now we have a mental reference to the size of a mole of gas under certain conditions. And that's great for comparing higher temperatures, higher pressures, smaller pressures, all that. So now let's see how we use STP. There's a lot of ways that we can use the molar volume once we know it. So if we said, okay, let's figure out the density of a specific gas at STP. Well, since I know the molar volume is 22.41, I'm going to just write that over here. The molar volume equals 22.41 liters. Then I can say, what is the density of chlorine gas at STP? Chlorine gas, by nature, chlorine is one of the 7 diatomic elements, so we're really talking about Cl2 here. Now, if we think of 1 mole of chlorine at STP, we know that our formula for density, D equals M over V. Standard formula for density, the ratio of the mass to the volume. So since we have chlorine at STP, if we had 1 mole of chlorine, it would weigh 35.45 times 2, which would be 70.90 grams. Well, 1 mole of chlorine at STP, by definition, takes up a volume of 22.41 liters. So now I have my mass, I have my volume, and I can calculate my density. Density is going to be 70.90 grams divided by 22.41 liters. Plug that into the calculator, and I will get a density of 3.16 grams per liter. In summary, STP gives us a reference point for using the ideal gas law. If I'm aware that the molar volume is 22.41 for the 1 mole of any gas. Does not matter what that gas's chemical formula is. I can use that value. Now, if I lost track of that, I can always use PV equals nRT as long as I remember 1 atmosphere, 0 degrees Celsius.